We can continue the discussion on associated colloids. What is associated colloid? At a low concentration, it will behave as electrolyte, and at a high concentration, it will behave as colloids. They are associated colloids. Soap is an example. Now we can see the mechanism of micelle formation. These figures will help you to understand the formation of micelles. Here you look, stearate ions. Stearate ions are obtained from soap. What is soap? Sodium salt of stearic acid or potassium salt of stearic acid. So here stearate ions. Stearate ions, you know, there is a large hydrocarbon nonpolar chain and a polar head. This negative sign represents polar head, CO minus group. So here, this part, CO minus group, that is in water, that is immersed in water. Then it will act as an electrolyte. And these hydrocarbon chains staying away from it. This CO minus group in water and the hydrocarbon chain staying away from it. But when the concentration increases and when it is passing the critical micelle concentration, or at a critical micelle concentration, the anions are pulled into the bulk of the solution, and aggregate to form a spherical shape. With their hydrocarbon chains pointing towards the center of the sphere. Hydrocarbon chains pointing towards the center of the sphere, with the CO minus part remaining outward. CO minus part remaining outward on the surface of the sphere. So a micelle is formed. So in dilute solution, it will be simple electrolytes and it will be the condition. And as the concentration increases and when it reaches critical micelle concentration, such aggregate molecular formations will occur. So now it is an ionic micelle because it has a charge, negative charge. You can see negative charge. As the concentration increases, the negative charges will repel each other. That is why the anions are pulled into the bulk of the solution and aggregate to form a spherical shape. Okay, I think it is clear. Now, cleansing action of soap. What is cleansing action of soap? From this figure, you will understand. In the clothes or in our body, the dirt will be attached through some sticking agents such as grease or some oil droplets. So the duty of the soap is to remove this oil droplet or grease from the cloth or our body. When we use soap, you can see this hydrocarbon part will dissolve in oil. And the negative head will be on the surface. And as the concentration of soap increases, the micelle formation will take place. So we can say the cleansing action of soap is due to the fact that soap molecules forms micelle around the oil droplet in such a way that hydrophobic part of the stearate ion is in oil droplet. The nonpolar part will dissolve in this oil droplet and the hydrophilic ionic part projects out of the grease or oil droplet. When you wash it with water, what happens? This polar part will dissolve in water and move along with water. So this grease also will be detached. So it is the cleansing action of soap. Okay, now we can see the preparation of colloids. Lyophilic colloids can be prepared very easily by direct method, simply by mixing dispersion medium and dispersed phase. But for the preparation of lyophobic colloids, some other methods are required, and we can discuss that methods here. First one, chemical method. Colloidal dispersions can be prepared by chemical reactions. Examples of these chemical reactions are double decomposition, oxidation, reduction, and hydrolysis. Any of these reactions can be used here. And you know, usually during the reaction, smaller molecules will form, and these molecules can aggregate to form colloids. If you want to prepare the colloids, especially we are discussing the formation of some salts here, any of these chemical methods can be used. Arsenious sulfide salt can be prepared by the double decomposition reaction between arsenic oxide and hydrogen sulfide. That is the first chemical equation. As2O3 plus 3H2S gives As2S3 plus 3H2O. Here As2S3, that will aggregate to form particles of colloidal size, and that is dispersed in water, and therefore you will get a salt, arsenious sulfide salt. Now sulfur salt can be prepared by the oxidation of sulfur H2S, oxidation of H2S with the sulfur dioxide. This is an example for an oxidation reaction. Oxidation reaction can be used for the preparation of sulfur salt. In sulfur, oxidation state is 0, and in H2S, oxidation state is -2. -2 is changing to 0. So oxidation. So H2S is oxidized by SO2. A method for the preparation of colloids. Here the product is sulfur salt. Sulfur dispersed in H2O. Gold salt. All these are examples for lyophobic salts. Gold salt is prepared by the action of auric chloride on formaldehyde. Auric chloride on formaldehyde. Here actually the reaction is reduction. Au3 plus is reduced to Au0. Reduction is the reaction. HCHO can act as a reducing agent. So auric chloride, when treated with formaldehyde in presence of H2O, 2AuCl3 plus 3HCHO plus 3H2O gives 2Au plus 3HCOOH plus HCl. You can see 2Au gold is formed. The molecules of gold aggregate together to form particles of colloidal size, and as a result you will get gold salt. Now ferric hydroxide salt can be prepared very easily by the hydrolysis of ferric chloride. Ferric chloride, when heated with H2O, hydrolysis will take place and FeOH will form. So ferric hydroxide salt plus HCl. These are chemical methods. Another important method, Bradig's arc method or electrical disintegration method. Bradig's arc method or electrical disintegration method. This method is using for the preparation of colloidal salts of metals such as gold, silver, platinum, etc. In this method, you see the figure. Here, the dispersion medium that is kept in an ice bath. The dispersion medium is kept in an ice bath. That is for cooling. You can see two electrodes which is very close to each other, and these electrodes are made up of the metals such as gold, silver, or platinum. If you want to prepare gold salt, take gold electrodes, and if you want to prepare platinum salt, take platinum electrodes. So here, if you are preparing gold salt, take two gold electrons and arrange them as shown here. You can see these ends are very close to each other. So when electricity is passed through these electrodes, high potential is passed through these electrodes, an electric arc will develop here. And due to the formation of this electric arc, high temperature will be generated and this part of the metal will be evaporated. And that evaporated metal, because of the cold dispersion medium, will condense readily to form particles of colloidal size. As a result, you will get a salt, a metal salt. So in this method, an electric arc is struck between the electrodes of the metal immersed in the dispersion medium. That heat will vaporize the metal, which then condenses to form particles of colloidal size. Another one is baptization. Baptization, that is a simple process. Baptization can be defined as the conversion of a precipitate into colloidal solution. How it is possible? By shaking it with small quantities of electrolytes. By shaking it with the small quantities of electrolytes. That is baptization. So baptization is the process of conversion of a precipitate into colloidal salt by shaking it with dispersion medium in the presence of a small amount of electrolyte. So that precipitate will change to colloidal solution when you add a small amount of electrolyte and agitate it. That is baptization. The electrolyte used for this purpose is called baptizing agent. So this method can be applied to convert a freshly prepared precipitate into a colloidal salt. And what is the principle behind it? What is happening during this baptization? And during this baptization, the precipitate adsorbed one of the ions of the electrolyte on its surface. Means either positive ion or negative ion. The precipitate will selectively absorb one of the ion, positive or negative on it. As a result, what happens? The surface will be covered with the positive charge only. Then, after absorbing particles, the positive charges on the surface, then that particle cannot combine with another which is carrying that positive charge. That develops a repulsion. Due to this repulsion, what happens? Further aggregation and conversion to the precipitate or a precipitation, coagulation, that is impossible. So, because of the development of this positive charge, the precipitates will be separated and further union of the separated particles are not possible. That is the principle behind this baptization. Now, purification of colloids. The colloids prepared by this method may contain a lot of impurities. Especially you can identify electrolytes. In baptization, we are adding small quantities of electrolytes. And in chemical method, you can see a lot of other compounds are present in it, electrolytes. If you examine the reactions, you can see. So we have to remove these unwanted electrolytes or excess electrolyte or particles from the colloidal solution. That process is known as dialysis. So what is dialysis? It is a process of removing a dissolved substance from a colloidal solution by means of diffusion through a suitable membrane. Semi-permeable membranes can be used. Ions are very small in size, so ions can move through the semi-permeable membrane. Ions are less than 1 nanometer, so they can easily move through the semi-permeable membrane. So in the figure you can see the arrangement. So here inside this, the colloidal solution is taken. And this one is the membrane, which allows the passage of ions only. It is covered with the membrane, which allows the passage of ions only. Usually animal membrane or parchment paper or cellophane sheets can be used. And it is immersed in pure water. It is pure water. And here water is introduced from here and water is taken out. That means here water will fill and a continuous renewal of water will take place. And therefore, what happens? The electrolytes coming out of this colloidal solution will pass through this water. So the concentration of ions will be less always here. So continuous flow of excess ions from the colloidal solution to this water will take place. And this process is known as dialysis. There are some more methods for the purification of colloids. They are electrodialysis. What is electrodialysis? We will use some electrodes here in water that will accelerate the movement of positive or negative ions from the colloidal solution to this water. If a negatively charged particle is present or negative ion is present here, that will be attracted by this positive electron. That is electrodialysis. Another method is ultrafiltration. Ultrafilter paper, that is a specially prepared filter paper, which are permeable to all substances except the colloidal particle. It will not allow colloidal particles to pass through it. It will permit ions to pass through it. And this ultrafilter paper is prepared by soaking the filter paper in a collodion solution. What is collodion solution? 4% solution of nitrocellulose in a mixture of alcohol and ether. Then it is hardened by dipping it in formaldehyde. Dip it in formaldehyde and dry it. Then you have to filter the colloidal solution using this ultrafilter paper. Then only the colloidal particles will be remain there as the residue, and others will pass through this filter paper. Then by mixing this residue with the dispersion medium, you can prepare pure colloids. Okay, I think it is enough for today, and we can continue the next